In this video, we're going to look at exponential functions. So first, we're going to learn how to solve an exponential equation. And then we're going to learn how to graph exponential functions. So first, let's look at these two exponential equations. And we'll notice that we have an unknown x in there. But compared to the problems we did before, let's say if we have x squared equals 81, in order to solve for x, we just need to take square root of both sides, square root, and put plus minus in front of the square root. And we can, because square root of x squared is equal to x, and square root of 81 is equal to 9. So we found x equals plus 1 minus 9. And notice the difference between these two equations we have. And the variable is in the base, but the equation we're solving, and the variable is at the exponent. So the equation, that's the type of equation we learned before. We call it a quadratic equation. But the equation we are looking at right now, if the variable is the exponent, we call it an exponential equation. And the way to solve it will be completely different. Of course, we cannot, in order to solve for the base, we could take, if the whatever the square, if it's square, we can take square root. If it's a third power, we can take the cube root. But right here, we're solving for the exponent, so we couldn't take the square root or the third root. The idea of solving exponential equations pretty much just similar to doing exponents. So first, let's go over the concept of exponent again. So we know if we take a number, let's say 9, we're going to take 9 to the first, that gives us 9. 9 to the second, that gives 81. And then to the third, we can keep doing this, which is 9 times 9 times 9. So that's 81 times 9, we get 729. So we can take the exponent of any number and to find an answer. But the exponential equation, right here, the exponent is unknown, so we don't know how many copies of 9 we're taking. But we know we're given the answer, which is 81. So we can, one way we could do is to try to just pick some numbers for x. And let's say, if we, like what we just did, 9 to the first is 9, which is not 81. But 9 to the second, we found out it is equal to 81. So we can say, okay, we are comparing these two equations we have. And notice that 9 matches 9, x matches 2, 81 matches 81. So that tells us x equals 2. So the exponent right here corresponds to the exponent of 9. So x is equal to 2. That would be the solution. The other way to do is to start from the right-hand side. So this is the first solution. I should look at the left-hand side and try to pick numbers for x and see if I can get the right-hand side number. And the second solution, which is not a common way to do, is we can rewrite 81 as 9 to some exponent. Apparently, it's 9 squared. So that tells us x is equal to 2. Because if the base matches the base, and the answer, the exponent are equal, these two exponents must be equal, because 9 to the x equals 9 squared. Now, similarly, we can do the same thing on the right-hand side. So what I'm going to do is we are going to keep the left-hand side and just going to rewrite 32 as 2 to some exponent. And after trying, we know 2 to the fourth is equal to 2 times 2 times 2 times 2, which is 16. But 2 to the fifth is going to be equal to 5 copies of 2, which gives us 32. Because 4 copies will give us 16, and times another 2, that gives us 32. we can rewrite 32 as 2 to the 5th. By comparing two sides, and these two exponential numbers are equal, which tells us, and also they have the same base, that tells us their exponents have to be equal. So that tells me 3x equals 5. And we can solve for x by dividing both sides by 3. So that gives us x equals 3/2. And again, we can check the answer by plugging number back in for x. Okay, so let's look at another two examples. In this one, we have fractions, but the idea of solving them would still be similar. So we can keep the left-hand side and try to rewrite the right-hand side as something with the same, as an exponent of the same base. So I'm going to try to rewrite 1 over 243 as 1/3 to some exponent. And to see that, we can just try a few. Let's say if I do square, that will give us 1 over 9. If I do a third, that gives us 1 over 27. If I do fourth, that's going to give us 1 over 81. So probably we should try at least a fifth. And we can kind of see that 1 over 1/3 to the 5th means 1/3 times 1/3 times 1/3 times 1/3 times 1/3, and multiply straight across. That gives us 1 on the top, and the bottom will be multiplying 5 copies of 3, and these two will be 9, these two will be 9 times another 3, and 9 times 9 is 81 times 3. That's exactly 243. So that tells me, yes, 1 over 243 can be written as 1/3 to the 5th. So now we can set, again, to comparing both sides of the equation, the base matches the base. That tells us that two exponents must be equal. So we have x equals 5. Okay, so similarly, we can do the same thing with the last one. The right-hand side is 625, and we're going to rewrite it as 5 to some exponent. So after checking, we know 5 to the 4th, which is multiplying 4 copies of 5, and that's 25 times 25, and that is 625. You can use your calculator to verify that. And after comparing two sides, they have matching base, which means that exponents must be equal. We have x minus 4 equals 4. And now we can get x by itself by adding 4 to both sides. And so that will be the final answer. Okay, so the left-hand side, as we can see from those examples, 9 to the x or 2 to some exponent. So these this expression, we call it an exponential function. And again, compared to the functions we learned previously, x squared. And we know from the section graph transformation, we know this is a parabola that looks like this. And you can compare them. The exponent and the base are switched. One of them has base unknown base x, but the other one has the unknown exponent. And so let's see what the graph would look like for the exponential function. By the way, let me sketch the graph for the parabola, x squared, the square function. But now let's compare it with the exponential function. All right, so to sketch the graph, we still use the same idea we learned before in previous chapters. Chapter 7 and chapter 9, previous section, also chapter 9. So we are going to make a table, because doesn't matter if it's a straight line or a curve, any kind of curve, you can always view the curve as infinite many points. So in order to get a curve or a straight line, we must have points. So all the lines, the basic, how do we form curves or lines? We have to have many, many points. So let's find some points. And in order to find the points, we pick numbers for x and try to get the values for y, which is also called f of x, so 2 to the x. And we start with, let's say, 0. So if x equals 0, we plug 0 into the function. We call it exponential function because the exponent is unknown. So we have 2 to the 0, which is equal to 1. Any number except 0 raised to 0 will be equal to 1. Now, let's plug 1 into the function. So we get 2 to the first. We're replacing x with 1. So we get a 2. Now let's put 2 there, 2 to the second, which is 4. And we can also get some negative numbers and plug in to see if it's going to get us anything. So we replace x with negative 1. We're going to get 2 to negative 1. We know the negative exponent actually means the reciprocal. So we get 1/2. Now we replace x with negative 2, and which means 1 over 2 squared. So that's 1/4. So we can do 2 squared and flip to get a 4 and flip 4 to get a 1/4. So far I picked 5 numbers for x. I should have 5 points. And the first point should be 0, 1, 0, 0 for x, and 1 for y. The second pair is 1, 2. The third pair is 2, 4. And the next pair is 1, 1/2. And last one is negative 1, 1/4. You don't have to rewrite them. You can actually just look at them. That's x, and these are your y's. But I will rewrite them so you can see them clearly. So now let's draw an xy coordinate system. Oops, not very straight. Let's plot those points in the xy coordinate system. So when x equals 0, y equals 1. And when x equals 1, y equals 2. So x equals 1, y equals 2. Got another point there. When x equals 2, y equals 4. Got 3 and 4 up there. Okay, so we got these 3 points. Now, when x equals negative 1, y equals 1/2. So it's going to be right here. When x equals negative 2, y equals 1/4. As you can see, I don't know if you can see the pattern yet. If you can't, pick some more points. For example, you can continue to pick 3 and pick negative 3. And notice if you pick negative 3, you're going to get a 1/8. It's going to become a fraction, or smaller and smaller, closer and closer to 0. And then we join those points. It's going to get us a curve. And on the right hand side, notice when you increase the exponent to 3, to 4, and 5, you're going to get a bigger and a bigger number. So it's going to go up forever. On the left-hand side, we'll pick negative numbers for the exponent. Notice we're not going to get negative. We're not going to get a 0. We're always going to get a fraction, which is closer and closer to 0. So we're going to try to make it get closer to and closer to 0, but never touches x-axis. So what does the graph look like for 2 to the x? It's a curve going up, completely above x-axis, not touching x-axis, and compare this curve to the parabola. Parabola has 2 sides. It's like going down and going up, but the exponential function goes up quickly. And that's why we say in real life, a lot of times we say the population is increasing exponentially, and that because it goes up very quickly. Now, let's look at another example. What if the base is not a number, it's a number between between 0 and 1? Make the chart the same way like I did before, and pick 0, 1, 2, negative 1, negative 2. And I'm going to replace x with those x values that I picked. And after I simplify all of these, because any number raised to 0 is 1, and 1/3 raised to the first is 1/3. 1/3 squared is 1/9. But 1/3 to negative 1 means reciprocal. Actually will give us 3, but the other one will give us 9. We plot those points in the coordinate system, and we join them, and we got this curve. And notice that this time the curve is going